Hello everyone, welcome and thank you to join us. My name is Frédéric Godmel. I'm the Executive Vice President of Power System and Services at Schneider Electric. I'm really excited to spend the next 15 to 20 minutes exploring with you the future of electrical grids and the key role electricity and electricity companies will play in enabling an healthier planet and a more sustainable future. I'm pretty happy to do that from a very special place here in Grenoble in our office building, our new office building at Schneider Electric that has been built to achieve a net zero and that is already balancing its production and usage of energy. To help me to explore this important topic, I've invited a very special guest to join me. Christian Ruby is the Secretary General of Eurelectric, an organization that most of you are likely already familiar with. Today, Eurelectric represents the power sector in more than 32 European countries and represents more than 3,500 companies in the field of power generation, distribution, and supply of energy space. Christian, it's an honor to have you with us today, and I'm extremely happy that you join us.
Frédéric, very happy to be here.
To begin our discussion, I want to take just a couple of minutes to set the stage and provide a bit of context. First, it's extremely clear that climate change following the pandemic has become a defining issue of our time, and the concern is rising. That's the top priorities for leaders, political leaders, economical leaders, and of course leaders in the power sector. When you look at the number, obviously climate change is primarily an energy challenge. Today, 80% of the global CO2 emissions are due to production, transportation, and consumption of energy. And guess what? There is a huge amount of waste. Means 60% of the energy we generate and use today is lost or wasted. Electricity in this equation is becoming the source of energy for the future. It is our best solution for decarbonizing the planet because producing electricity can be done in a green way, it's super flexible, and it can be used locally. In many ways, this is a problem we have to solve together. It's an enormous challenge. It's a very big opportunity as well. Perhaps a way to visualize this challenge, because we like to look at curves, is to say, well, what we have to do now is to flatten the curve. We've been used to do that with the pandemic. We have to do it with energy. Means we need to flatten the curve and start a fast decrease, not in 10, 20 years, right now. We've been living in the past in what we have called the age of fire. In order to get energy, in order to get power, we have fueled massive industrialization, a growth of population, and obviously prosperity. It comes with a cost, and the cost is this curve of emission of CO2. And we have now to change our model. We are at a critical juncture. If we don't take actions now, there is no chance that we limit the climate consequences. So we have to act now. The good news is that we have solution to be able to curve it down and limit CO2 emission and stay in the 1.5 degree climate change. So Christian, we have this incredible task ahead of us. And DSOs are clearly driving their part in a more electric world in this transition. What do you think should DSO be focusing on today?
Thank you, Frédéric. I really like your expression, an age of fire, because that's exactly what we're coming from. And we should be moving into an age of electricity, essentially. And that's also why in Eurelectric we're calling the 2020s the electric decade. In many ways, the electric decade will also be the decade of the DSOs because we're facing a massive change in the electricity system. We're going towards a much more decentralized system. We're going towards a system that is going to serve bigger parts of the economy, bigger parts of the end-use sectors, and therefore basically revamping the entire system. The DSOs will be at the heart of all this, and I'll just give you 3 examples of just how big the opportunities but also the challenges are that DSOs will be facing and what they should be focusing on. First off, in order to reach the targets in Europe for renewables and decarbonization, we're looking at adding some 500 gigawatts of new renewable capacity over the next decade, 60 to 70% of which will be connected directly to the distribution grids. Imagine I told you that 10, 15 years ago, that would have been unthinkable. But that's the reality that DSOs will be facing in the next years. Another key focus point and challenge is the electrification of transport. We expect anywhere between 40 and 70 million electric cars on the roads in Europe by 2030. That's a big span, but regardless, it's very big because we're coming from around 2 million today. So the curve is very steep, and this is really something that is going to change the nature and the operations of the DSO grids. A third point is the steep increase of self-consumption. We expect some 40 gigawatts of self-consumption by 2030 in order to reach the targets. And how much is 40 gigawatts? Well, if you translate it into solar panels of 200 watts or 250 watts, you're looking at 160 million panels. We know that the units are going to be bigger that we connect, but we still get an idea from this figure of those incredible proportions of the decentralization that we're facing. So to cut it short, we're looking at a fundamental systemic change also for the DSOs, and that change itself needs to be at the heart of what all DSOs are thinking about in strategic discussions.
Thanks, Christian. What are some of the key enablers that will make this kind of smart and dynamic low-carbon grids possible?
First of all, I think it's important that all stakeholders recognize the critical role of the DSOs in this transformation. And today, I don't think that's the case. We see a lack of that mindset with the regulators, in my view, but also at European level, where the focus is too much on transmission today. We need to, first of all, get that mindset clear and get that recognition that DSOs are at the heart of this transformation and integrate that properly in the grid planning. We're talking about investments of some 400 billion, and if we don't get that recognized and planned, we're not going to get there. The second thing is that we need a tariff design that really can help drive this transition. The tariff design needs to be contemporary and reflect the investments that the DSOs need to make, both physical, but also very much the digital investments. That's also different from the past. And moreover, the tariffs need to help incentivize the customers to choose the electric options. So we need changes to the tariff design in many member states. And the third thing is about the cooperation between DSOs and the regulators. Today, there's too much red tape. Okay, there's a plan, let's see, we can discuss it, and then you get the stamp from the regulator, and 4 years later you can start to build. We're talking about 10 years where everything needs to happen. We need more freedom for the DSOs to go and do what's necessary. We're having hundreds of different operators in the market do stuff at the same time. People building solar farms, people installing batteries at the harbors, people electrifying their parking lots, and so on and so forth. If the DSOs are not allowed to make those investments, connect those things, and have to wait for the regulator every time, they will become the bottleneck and the source of frustration in this. So there needs to be that freedom to operate. Otherwise, we will have problems.
Thanks a lot, Christian. Super insightful. It's clear that DSO will drive the creation of the smart and dynamic grids of the future. And without the DSO, without the right supply of energy, all our story will not work for sure. Of course, industrial and user, consumers, office building, all companies will have an important role to play. Let's look at a few numbers. Today, 15% of the global energy-related greenhouse gas emission comes from getting oil and gas out of the ground, transporting it and getting to the consumers. This will dramatically change with a massive use of electrification in many processes. If we look as well at what we need to do to achieve net zero by 2050, we need to lower the energy demand by 8%. Keep in mind that at that point, the global economy will be twice larger. So going into reducing the demand and changing the demand profile is extremely important. Regardless of whether we're talking about DSOs, industrial end user, office building, or consumers, there is something that is common to all those professions to create a low-carbon future. It is the digital part of the equation. It is to capture, interpret, and act with data around energy. Digital technology is also a way to improve monitoring and reporting on sustainability measures across the value chain. Today, most companies have taken commitment, most large corporations, and we see now small companies taking commitment on sustainability. With digitization, you can monitor and you can act on those emissions. A few examples of things that eventually use digital. Renewable cannot be injected properly on the network without the right combination of software and hardware. Of course, efficiency, energy efficiency, the fact to use energy just when we need it and making sure we eliminate the waste of energy that are in every processes, in many buildings, in many operations today. And last but not least, and it was mentioned by Christian, is the world of prosumer, where consumers will as well, in some cases, produce their own energy, have storages capacity, and they will become actors of this energy equation. To allow that, of course, you need to have flexibility because energy, and especially renewable energy, is not something that is constant, and you need to be able to introduce flexibility. The best way to understand the full impact of those digital technologies is really to look at examples of today. I'll talk about a couple of companies we've worked with recently at Schneider Electric, and then I will go over to you, Christian, to share the same example in your domain of Electric that you have launched, for example, in Germany. Let's start by taking the example of Coreso. As you know, Coreso's job is to support the European transmission system operators, the TSOs, to ensure the security of the European electricity supply on a regional basis. So an incredible challenge, of course. Coreso does this by aggregating data from many different European TSOs. They analyze those data to build the big picture of what is the transmission load across the continent. It's much bigger than any single TSO can see. It's really something that goes around the profession. And then the Coreso engineers and the experts can use data to anticipate, to detect. For example, they can look at voltage or frequency problem in the network, and they can help the TSOs to coordinate almost in real time so that they find a solution and they solve the problem before it leads to a serious issue. I want to say that in the last 10 years, they have been working extremely successfully to help the transmission operators to avoid what could have become very serious outages. At the heart of the system is a software from OSI Soft called PI System that help TSO to guarantee a more efficient and a secure transmission grid. Of course, this system can be deployed to other companies, DSOs, or users that want to manage energy data. And with the variability that we have now with electricity generation and demand, those type of data analytics are extremely critical. It is more important than ever. And Christian, I know you're working super hard on flexibility initiative. Can you please tell us more on your domain?
Absolutely. Looking more at the systemic level, I really agree with you that digital is a sine qua non for a successful transition. We see it with integration of renewables. We see it with controlling of the load, all the DSR options that are going to be needed to make sure that we basically have this more flexible demand side. And we have some very interesting examples across Europe where stakeholders are coming together to create successful digital systems. There's one system up in in the northern parts of Germany, where 31 companies have gone together in a consortium to create a digital solution for handling their energy system. Up there, they are dealing with a luxury problem, which is they have an average of 250% renewables in the grid. That means they have 2.5 times as much renewable as their consumers actually need. So what do you do with all that? You can transport it on, but it raises, of course, a lot of questions around redispatching, flexibility, how to turn up and turn down, and so on and so forth. All that is regulated with digital solutions, and they're building local flexibility markets. One thing which I think is going to be absolutely critical in this more decentralized world. You can imagine, 10 years from now, when 60% of all the new capacity that's been added over the last 10 years is on the grid, how are you going to regulate that 2 voltage levels away at the wholesale market level? That's going to be very difficult. We're going to have to put in place those local flexibility markets that allow for the optimization also at a more local level. Specifically in Electric, we are also studying these things, of course, and constantly coming out with new recommendations and new insights. And in November, we're coming forward with a new report that basically provides some recommendations for how we can increase flexibility both at the grid level, but also in other parts of the value chain.
It's clear that the initiative you are driving are really helping DSOs succeed in their work to design and build the sustainable grids of the future. Thanks, Christian. It has been really a great discussion and a lot of examples, so really thank you for joining us today. Electric is doing an amazing work, and we're absolutely proud to be one of your partners in your journey to help DSOs for a greener tomorrow. As you know, we're all in this together, and if each of us, companies, individual regulators take immediate action, then we know that the 1.5-degree scenario is still achievable. That is what is in front of us. Thank you all.